Hello?
Yes,
Yes.
1 minute, wait 1 minute. I'm connecting headphones.
Hmm. Connected?
Yes, let's start.
Hmm. So yesterday we had started complex numbers, right?
Yes.
Okay. And in complex numbers, we have seen what is a complex number, what is an imaginary number. Tell me what is an imaginary number? Tell me. Today's Thursday, no? What is an imaginary number?
Hello, can you hear me now, sir?
Yes, now you are audible.
Uh, yeah, you were muted for a bit. What were you asking?
I am
You
asking
were
you
asking something.
what is an imaginary number?
An image number is which is not real or cannot be in that uh, uh, ax square plus bx plus c form.
Uh, Ax plus bx plus c form. I is equal to square root of minus 1.
Ah, yes.
Square root
Value
of
is
minus 1
square root of
is
minus
an
1.
imaginary number.
Yes.
Next, what is complex number? What is complex number?
That standard form a plus ib,
Hmm.
uh, which is denoted by z.
Oh, okay. Give me an example of a complex number.
3 plus 7
Okay, so we have learned yesterday imaginary number, then complex number, then we have seen what? Z bar. Complex conjugate of a complex number,
yes,
right?
and
What is
Argand's
complex
diagram,
conjugate?
where we change the sign of the imaginary part.
Okay, we change sign of imaginary part of the complex number. Okay, that is called as complex conjugate. Then we have seen equality, equality of complex numbers, right? And last part we
Yes,
have seen Argand diagram, right? Argand's diagram. So
yes,
these topics we studied yesterday. Okay, is it clear?
yes,
Hmm. What? First, imaginary number, complex number, examples of complex number. Then third, complex conjugate. for equality of complex numbers. Equality of complex numbers, fifth point, Argand's diagram, right? Have you seen this yesterday? Argand's diagram?
Yes. Argand's
Okay.
diagram.
Okay, what is
Yes.
Argand's diagram?
There are two axes where one is an real axis and
Hmm.
second is an imaginary
Hmm.
axis. Then we put that we can represent the numbers which are given.
We can represent any
And
complex
then
number.
polar
We can
polar
represent any
numbers that
complex number as a point on complex plane. Argand's diagram, right? Then
yes,
polar form of a complex number and exponential form of a complex number. These were the topics that we
yes,
studied yesterday. Okay. And then we studied algebra of complex numbers, right? Algebra of complex numbers. In this, we have
yes,
studied
and
addition of
subtraction.
complex numbers and subtraction. Okay. Now today we will study scalar multiplication. Okay. What? Scalar multiplication of complex numbers. Then we study multiplication. Then we study division of complex numbers. Okay. So these three important topics we will study today. Scalar multiplication, multiplication and division. Okay. Let's start one by one. Hmm. First, scalar multiplication. Okay. Now let's say Z is equal to A plus IB is a complex number where A, B are real numbers. I is equal to square root of minus 1 is an imaginary number. Okay. So this is our Z, and let K be any real number. K is any real number. Okay. This K, we will call it as a constant. We call it a constant. Right? Is there any doubt?
No,
Okay. Now, the multiplication K Z, that is K multiply A plus IB. This gives or results in Ka plus Kb into I. This is called scalar multiplication. Is multiplication by scalar K. Hence it is called as a scalar multiplication. Let's study in detail with examples, with the help of examples. Okay. So let's take an example where Z is equal to say 3 plus 4I, right? And K is equals to say 5, right? Then 5Z will give us what? 5 multiply 3 plus 4I. Is it clear? So this gives us what? 5 into 3, open the bracket, plus 5 into 4 into I. So this results in 15 plus 20I. Got it? 15 plus 20 I. 20 I. Got it? 20 I. 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 20 Got it or not?
Yes.
Okay. Next. Let's say z is equal to. Now you give me an example of z, complex number.
4 plus 7i.
4 plus 7i. Okay. So let's take 4 plus 7i. And k is, let's take what? K equal to
2.
minus root 2. Let's take minus root 2. Now it is a real number.
Okay.
Okay. So this scalar multiplication kz, that is over here minus root 2 z, will give us what? Minus root 2 into bracket 4 plus 7i. So this gives us what? Minus 4 root 2 minus 7 root 2 I. This is multiplication by scalar k equal to minus root 2. Is there any difficulty in this scalar multiplication?
No, can I write this?
I will give you time later on. You just know, make notes of it later on. Okay. Have you understood this now?
Okay.
While solving
Yes.
problems, if you find any difficulty, then I will ask you to write it down. Okay.
Okay.
These notes you can make it later on. Okay. Now next,
Okay.
multiplication. Let's study now next topic. Third, fourth, multiplication. Multiplication. Okay. So let's take Z1 as A1 plus IB1, a complex number. Z2 as A2 plus IB2 as another complex number. The multiplication Z1 multiply Z2 is equal to, see, A1 plus IB1 multiply A2 plus IB2. A2 plus IB2. Got it? Now we will do what? We will open up these two brackets and multiply. Likewise, we did in what? In polynomials, linear polynomials, in quadratic polynomials, binomial multiply by binomial. At that time, we have seen these things. We know how to multiply x plus y into 3x plus 4y. Right? This bracket should be multiplied to this bracket. For that, what we do, we take first term of first bracket and multiply by that to second complete bracket. A2 plus IB2. Then plus this part plus IB1 into second bracket. A2 plus IB2. Right? So this will give us what? A1, A2 plus I times A1, B2 plus I times B1, A2 plus I square, that is I into I square, B1, B2. Now this will give us what? A1, A2 plus I times I square times B1, B2 plus I taken common A1, B2 plus B1, A2, right? Now, what about this I square? Now, this I square is what? Square root of minus 1, its square. This gives us what? The square is cancelled with the square root, and this will give result in minus 1. So, I square is equal to minus 1. Square of the number is minus 1. That's why it is an imaginary number, no? So, this will give us minus. So, here this sign will change into minus. So, we get what? A1, A2 minus B1, B2, right? Plus I times A1, B2 plus B1, A2, right? Got it or not?
Yes.
So Z1 multiply Z2 is this thing. A1 A2 minus B1 B2 plus I times A1 B2 plus B1 A2. Right? Have you understood? Now you don't need to remember this formula. This is quite obvious. We know how to multiply two brackets, we have to open the bracket, how to multiply these things. We already perform such calculations. Okay, so we just have to use that thing, right? Is there any doubt?
Okay.
No.
No.
Let me give you an example based on the multiplication. Example Z1 equals to, let's take simple example, 1 plus 3i, right? And Z2 is equal to, Z1 is 1 plus 3i, and let's take Z2 as 2 plus I, right? Right? So
Yes.
multiply Z1 into Z2 will give us what? 1 plus 3i into 2 plus I. So this gives us what? Okay. So first bracket, first number, second bracket. 1 into 2 plus I plus 3i into 2 plus I, right? Have you understood this or not?
Yes.
Okay. Now multiply this 1 to this bracket will give us what? 1 into 2 plus 1 into I plus 3i into 2 plus 3i into I will give us what? 2 plus I plus 3 into 2. See this 3 into 2, 6i, right? Plus 3i square. Now we know this I square is minus 1. So this plus 3 into minus 1. I square is minus 1. So this gives us what? 2 plus this 1i plus 6i. 7i plus 3 into minus 1. Because what? I square is minus 1. That's what is the meaning of an imaginary number, no? So this gives us what? 2 minus 3 plus 7i will give us what? 2 minus 3 gives us minus 1 plus 7i. This is real part of complex number minus 1, imaginary part of complex number 7. Understood this thing?
Yes.
Hmm? Or is there any doubt?
No.
Okay, now let's take few examples from textbook. We'll see that theoretical part, properties of complex numbers, multiplication, addition later on in detail. Okay. See, you can now solve this example. You can now solve this. No, this example you can solve. This you can simplify and solve. Right? Try to solve these examples. These three examples: 1, 2, and 3.
Okay.
This also you can solve. Question from third question. Example from third question. Okay.
Yes.
Understood this or not?
Yes.
Get started with question number 3 only. Let's first solve question number 3 only.
Can I once 1 minute see that PDF so I can know the steps how to solve this 1 minute?
Hmm.
Okay. 1 minute only.
Hmm.
Okay.
Hmm. Hmm. Now this. Hmm. Done.
No.
A plus ib into 1 plus I. Multiply that 2 and that whatever real imaginary parts you will be getting, compare that with 2 plus I so that you can find value of A and B with that comparison. Done.
I got one.
A equal to or B equal to?
Both. A is equal to 3 by 2 and B is equal to 1 upon 2. Minus 1 upon 2.
A is equal to, let me check.
That third last question I did.
Third slash, that's what I said.
That only I did.
Hmm. Wait a minute. Let me check answer. Third मधला last. Sixth है ना? equal to a equal to a is equal to what? Hello,
3
hello,
by
sir.
2 and b is equal to minus 1 upon 2.
Okay, very good, correct. Okay, now solve next question, fourth question, this one. Now here you don't have to find a and b. Here you just have to find the multiplication. Your answer is correct. Find this question. Find this multiplication.
Do I have to multiply the brackets with each other? That's it, no?
Yes, that's it.
Okay.
Hmm.
And I have to put i's values, no, while solving minus
No,
1
I
and
square's
1.
value only -1. I square only -1. Wherever there is I, keep it as it is, and wherever there is I square, take it in place of I square.
Minus 1.
Right.
Hello? Oh, yes. I got till here 1 plus 2i bracket and then bracket minus 2 plus I is equal to minus 4 minus 3i. That's it, I got.
Till where?
1 plus 2i in a bracket and
Hmm.
then minus 2 plus I in a bracket is
Hmm.
equal to minus 4 minus 3i.
Correct. Very good.
Oh, that's it. Okay.
That's it. That's the multiplication of two complex numbers, and the multiplication
Oh,
resulted into what? Multiplication. And whatever answer you got, what answer you got? -4 -3, right?
one, yes, at b
That
is equal to side.
okay. That -4 is real part of the product or multiplication, and -3 is what? Imaginary part of the multiplication. That's it.
Okay.
Okay. So is there any doubt in the multiplication now?
No.
Okay. Now let me tell you how to divide a complex number by another complex number. Let's do that part. Okay. Third, fourth, fifth. Division. Division of a complex number. Okay. Now see. Let's take an example. Okay. Example from textbook only. Let's take an example from textbook only. Okay. Let's take this example. Which one? This one. 1 plus I, 1 minus I raised to -1. See. 1 plus I into 1 minus I raised to -1. Now we know power -1 means what? It will go in the denominator. 1 minus I, okay, raised to power plus. So 1 plus I divided by 1 minus I. Okay. Understood this? Understood this or not? Yes.
Yes.
Okay. Now see, we multiply both numerator and denominator by complex conjugate of denominator. ठीक है, multiply both numerator and denominator by complex conjugate of denominator. Okay, so for this division 1 plus I divided by 1 minus I, we get what? 1 plus I in a bracket divided by 1 minus I in a bracket and multiply by complex conjugate of denominator. Now what is complex conjugate of denominator? 1 plus I. Is it? Yes, isn't it? Please reply yes or no. Say yes or no.
Yes.
Okay. Now, uh,
Yes.
what we just did, this 1 plus I. See,
We multiplied by conjugate.
1 plus I. Its conjugate will be 1 minus I. Its conjugate will be 1 plus I. So we took this complex number and multiplied and divided. Okay. Now, what we do? We multiply numerator with numerator. 1 plus I into 1 plus I and 1 minus I into 1 plus I. Okay. Now, here, what we are getting? See, numerator a plus I, 1 plus I, 1 plus I. That is 1 plus I square. Compare this with a plus b square and use identity. And in the denominator, see, it is kind of a minus b, a plus b. This will result in a square minus b square, isn't it? So these are the
Yes.
two identities that we are going to use now. A square plus 2ab plus b square for this example, particularly in the numerator, and this as a second identity, this will be helpful as we are going to multiply by new complex conjugate of denominator every time while finding multiplication division. Okay, so this identity that squared in the red rectangle, highlighted in the red rectangle, will help us in each and every division, in each and every example. Okay, so numerator becomes what? 1 plus I squared divided by denominator 1 square minus I square. Now this will result into what? A plus b square. A square plus 2ab plus b square divided by 1 square will be 1 and I square will be minus 1. Now denominator become real number. Now this 1 plus 2I minus I square is minus 1. I square is equal to minus 1. Now this gives us what? 1 plus 1. And final answer is this. I square is minus 1. No. So there should be minus 1 only. Okay. Now this 1 minus 1 is cancelled and becomes 2I divided by 1 plus 1, 2. Final answer is I only because this 2 is cancelled with this 2 in the usual multiplication. So we have got what? Given division of two complex numbers is I only. If this is Z1 and this is Z2, then this resulted into what? Z1 upon Z2 resulted into what? I only. Understood this? Understood or not? Let me
Yes.
explain the steps again. Okay.
Yes.
Simply while dividing one complex number by another complex number, You just take complex conjugate of denominator complex number and multiply to the numerator by complex conjugate of denominator and multiply to the denominator by complex conjugate of denominator. Okay. This is the first step of division. Understood? Please reply yes or no. Hello? Hello?
Sir, your voice is breaking continuously.
Still it is breaking?
Hello?
Yes, still my voice is breaking. Am I now audible? Hello? Have you understood this? Hello? 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 Hello?